Now, you may have noticed, it's Friday, it's 1 o'clock, we're all tired, we ate lunch. This is going to be a dangerous class. There are no cool demos here, right? We are just going to be working through 2 very exciting physics problems in preparation for our test next week. So in about 15 minutes, we'll have some sort of loud noise where I'll clap to wake you all up. And there will be a couple clicker questions. So if you fall asleep, make sure the person next to you nudges you when there's a clicker question. The first one we want to look at is what we started with briefly on Wednesday. And that is the football player trying to make a field goal. So we have the basic situation. Here's the football. From the side view, here's the field goal. We're going to kick it at an angle of 35 degrees with a speed of 25 meters per second. And the question is, does it clear the 10-meter high field goal that is 35 meters away? This is the first problem we want to solve. And we already talked about the question of what does it mean to clear it versus what does it mean to just clear a field goal. So let's look at how this would go. We have our given information is we know that it's 35 meters to the field goal. The bar is 10 meters high. And we know V naught is 25 meters per second at 35 degrees above the horizontal. Now, one of our things that we've said a lot in trying to figure out how to solve physics problems is the best first step is always to organize our information in a useful way. And knowing that this is kinematics and the question is, do we make it? We first convert this to a physics question, right? We're going to have to find something that we calculate. And what we decided is we have to calculate the height at 35 meters away. And since we're doing height, we're doing displacement. So we will start with our displacement equation and see if this has enough information for us to get started. And we drew our picture. Delta x equals 35 meters in a horizontal direction. We know V naught t. Well, we don't know t, but we know V naught. This is 35 degrees, and the V naught is our 25 meters per second. We don't know how big 1/2 gt squared is yet because we do not know t. But we know it must go straight down. And our question is, what is that height? Keeping in mind, right, that our full displacement as a vector is to this point here. That's where we are landing. We're landing some 35 meters away at some height in the y direction. And once we're here, okay, having organized these key pieces of information is where we pause and ask, do we have enough to solve for the thing we want to find, which is height? And if we look at this, we can immediately write down one useful equation. From the tangent that has height in it. And what else in this equation do we not know? I heard people whispering it. What don't we know? Time. Once again, notice if you had been listing things from the problem, there is no place here in this problem where I find time mentioned at all. And that is, again, going back to what's been said a lot. And I know it sounds like I'm beating a dead horse, but we're going to really drive this home these first 3 weeks. Time is not given, it's not mentioned as an unknown. It is this sort of thing you have to notice in doing the physics problem. And you may have noticed I'm not doing, and I'll come back to this at the end of the lecture, I'm not doing that standard thing you probably learned either in high school math or high school physics somewhere, which is I'm not listing all my knowns and unknowns right at the beginning. Because 80% of the time in this class, that won't help you. 20% of the time, if you do that, yes, that'll show you immediately what the equation is and you can solve the problem. Certain easy problems you can do that way. But most of the problems, if that's the first thing you do, it won't be obvious what information is missing. You have to organize the information differently. And that is why I like to organize it first in my picture, because I know the physics concept that's going on. I know we're moving under constant acceleration. So I know how to represent that as a diagram, and it will reveal very quickly that time is something I need to know. And by looking at my triangle, I can immediately see that this side is completely known, and this side is only missing time. And so by writing down my cosine of 35, right, being the 35 meters divided by the v naught t, I am now done, because I have my two unknowns and my two equations. And so let's look at this. This one right here becomes v naught t times cosine of 35 equals 35 meters. Now, when you get better at trig, right, you can take this and you'll be able to skip that step and write it right away that way, because you know what you're looking for is time. So having it in the denominator doesn't help you. Okay? And this will tell me that time is my 35 meters divided by my v naught cosine of 35, and you will get 1.71 seconds. And if I look up here, I have h plus 1/2 gt squared equals 35 times my tangent of 35, or h equals 35 tangent of 35 minus my 1/2 gt squared. And when I plug that in, I will get 9.9 meters. So am I done? No. What's my answer? No. Now, I will be honest, I try very hard on the exams never to make it this close. Right? Because there's a chance if you round really badly, you'll get the wrong answer. Okay? And remember at the beginning I said I don't worry too much about significant figures, but they are important. You don't want to over-round. You want to keep enough digits that until the end, you know you're being pretty accurate, and then at the end, you round. Because if you have these two numbers you're subtracting and they're kind of close, and you round them differently, you can get the wrong answer. And sometimes, see, mastering physics isn't super careful with that because it's generating random numbers for you. So you can get, for your individual problem, one where the numbers are close. And you do have to be careful. So that's one thing. And that's another reason I like to keep the variables as long as possible and kind of plug in that last step. There's less rounding that I do along the way, and I'm less likely to make errors go along with it. Any questions on that? Notice the key thing was we did not set that equal to 10 meters. I cannot tell you how many times in a problem like this, okay, Keep in mind what is about to happen is wrong. People will have an idea, right, like V naught t 1/2 gt squared. They'll have the 35 meters, and they'll have h. And they'll do something like this. Maybe they'll be working in coordinates and components, and you've got the 35 degrees. Okay, and they'll have written down maybe for the y direction that they have h, the height I end up at, is a v naught t sine 35 minus 1/2 times the 10 meters per second squared for g. So that's g times t squared. And they go, oh, wait, I need to find t. So they'll plug in 10 meters here, because that was given in the problem. They'll solve for t. And then they'll say, oh, wait, no, now I need to know, I don't know how far I go at that t or something. And then they'll plug that t in somewhere. And sometimes they'll even plug the t back in here, and they'll solve for h and get 10. And go, OK, it just made it. So you can see how all sorts of things can go wrong when you plug in 10 and then solve for t and then plug t in and solve for h. And trust, you laugh. But in the panic of a test, when you're just looking at numbers and variables and you're not thinking carefully about your picture, that can easily happen. And that's why I do the problems the way I do for you as an example, and not by just listing letters and numbers. So keep in mind, everything I just said was wrong for the most part. Any questions? Clicker time! Yay! Wake up. One of the things you want to do as you prepare to study for next Friday is try and take the problems I did in class, take the problems you did in discussion section, take the problems you did in homework, and change them just a little bit to a different question. So let's suppose I did not tell you how fast the ball was kicked with. We knew it went at 35 degrees. We know you're 35 meters away. And we know the goalpost is 10 meters high. And I asked you to find the minimum speed to just make a field goal. What of these would you do? A, solve for the speed as a function of height and take the derivative. Finding the minimum value, by using 0 and all that. Solve for the speed required to have a height of 10 meters, a distance 35 meters away. Solve for the speed required to go 35 meters at any given height. Or this is not a question you can answer because we didn't do it in class, or for some other reason. Excellent. I'm a genius. I've taught you so well. I take full credit for this. Everybody got it right. Well, not everybody, 88% of you, but that's everybody as far as I'm concerned. No, don't feel bad if you got it wrong. I still count you. You're still a person. This is what we have to do. And notice, from a physics point of view, you've just learned a new useful word, minimum. Right? You have to know something about what's going on here, unfortunately or fortunately. If I am kicking a ball, and I have to clear some height h, and I'm kicking it from here, right? And I just managed to clear it. If I kick it any faster, you have to know that I'm going to clear it better. That's just the way it works, because you'll be able to be going farther. So that's the minimum speed you can use. Now, and that's why you want to just hit it. So any questions on that? It just saved us a lot of time. You all got it right. So now we move to problem number 2. Staying with our football theme. Sometimes it's baseball. I should have used baseball because we're in the spring. But, I last taught the course years ago in the fall. So we got a lot of football examples. Playing football with your friend, you throw the ball at an angle of 30 degrees above the horizontal. 3 seconds after your friend starts running in a straight line away from you at 6 meters per second, your friend started right next to you, catches the ball at the same height with which you throw it, because you're exactly the same height and they don't jump up. And if they run at a constant speed, how fast must you throw it for the catch to be made? Many of you, at the beginning of this class, when I asked what you wanted to get out of it in that first quiz, wanted some practical, real-world, useful examples. So here you go. The next time you play football, have your calculator with you. And while they're rushing at you, have a little paper, pencil, quickly draw out. You got about 3 seconds to figure out how fast you have to throw it, because that's how long you're waiting. So you can do that, right? What are we going to do with this problem? First, I didn't even bother to make it a clicker question, because I know we've mastered it so much. What does catch mean? It is a collision, and it means we solve for what? Yeah? Okay, say it loudly together. All together. Say. That was not all of you. That was still not all of you. One more time. I think that was just the same group louder. We're solving for the same position at the same time. You may think that's obnoxious, me trying to get you to say it. But trust me, you need to remember that in a week. Repeating it here can help. So we need the same place at the same time. Let's figure out and draw our situation. And what I want you to do is, before I draw it, okay, assume, like we've been doing all along, that this is what we're going to use as our main equation. Keeping in mind that we now have two things. We have the ball, and we have the person running. Draw for yourself a useful picture for this. I'll give you the key facts. You're throwing it at 30 degrees. There's a 3-second delay between when they run and you throw it. They are running at a constant speed of 6 meters per second, and you want to know how fast to throw it. I'm going to sneak around and peek at your drawings, causing real havoc for the camera. The question, remember, was, my friend starts running, standing right next to me at 6 meters per second. After 3 seconds, I try and throw a football to them. I throw the football up at an angle of 30 degrees from the horizontal, and I want to know what speed I need to throw it so they just make the catch. So I'm throwing it at 30 degrees. After a 3-second delay, they're running with a constant speed. We started at the same place, and he catches it at the same height I threw it from. And I want to know how fast I threw it. Now, though you all got a lot of our clicker questions right, I'll be honest, I walked around, and by this point, you really need to be able to draw these diagrams quickly. Now, I realize the homework's not due till Sunday, but you worked in discussion section. We've done some examples. You want to be very, very quick with converting this into the diagram and understanding what that really means. So what do we have? The first thing I can easily draw is the displacement of my friend who's running. Because they run for 3 seconds. So that's V player times the 3 seconds that they run for. They run for 3 seconds at a constant speed, and then they run for some unknown amount of time at a constant speed. And this is the time the ball is in the air. Right? That's the motion of the person running. I say hike, they just start running. 3 seconds later, I throw the ball, but they're still running. That's all they do. And so now I know their delta x. That was the part of the motion that was the easiest. Once I know that, and I know I have a collision, I know the ball has to start here, because we said we started at the same place, and the ball has to end here, because they catch it. And the ball is only in the air for time t. And what the ball does is it has some 1/2 gt squared because it's in the air, so that's got to end right there because I'm adding my two vectors. So here's my 1/2 gt squared for the ball. And I know for it to add correctly, v naught t must go from here to here. And what I was given was this was 30 degrees. And what I needed to find was v naught here. That's the question. And once again, I'm in a situation where there was one other thing I don't know, which is t. And I would not have known that from the problem. Right? The problem never mentioned the time the ball is in the air. So, having said all of that, let me ask you this clicker question. I forgot I had this clicker question. I think I just made it easy for you. What information is missing from the problem that is needed to solve it? How far the pass is, how long it is, how fast the ball is going when it's caught, how long the ball is in the air, all of the above, or none of the above. The problem gave you all the information you need. If you forgot the answer because I wrote it down, and your neighbor remembers, you might want to check with them. Five more seconds. 4, 3, 2, 1. And done. Excellent. Even though I gave the, oh look, I gave the answer and we got 62%. That's good. I don't think I made a slide with the answer. No, I did not. So the answer is, the piece we're missing is how long the ball is in the air. Notice, once we did our diagram, that's what becomes obvious. That's why I do the diagram, right? Notice, I don't need to know how long the pass is, right? There's no point where I'm going to be solving for this distance, right? This distance is given by this expression. So let's write that even bigger. What I really have in a nice big triangle is I have v, the speed my player is running at, times t plus 3 seconds. That's the time in the air. And that's the delay time. And that's equal to my 1/2 gt squared. And g I know is 10 meters per second squared. And that angle is 30 degrees in this problem, sorry. That angle is 30 degrees, and I have v naught and I have t. And any time I draw one of these triangles, I know I can always get at least two independent equations. And so I check, and sure enough, I only have two unknowns. The thing I want to find and time. So I am done. And once again, it was something that was never mentioned in the problem that provides the key step and connection in solving the problem. And a number of you have asked, you have trouble recognizing the implicit information, what's missing. Notice, nobody is really good at recognizing it just from reading the problem. I mean, I've done tons of these, so I sort of can. But what I'm really doing, even if I'm just doing it really fast, is in my head I'm drawing this picture, or I'm drawing it out. It's only once you sit down and translate the information you were given into a clear diagram does the missing information you need show up, right? By making this diagram, I force myself to write things with a t in it. And then it becomes clear that t was missing. If delta x down here was the thing that was missing, that would become clear. And that is why we draw these diagrams. And the same thing will happen with forces, and the same thing will happen with energy. We'll have ways of diagramming the problem that reveal the missing information. Any questions on that? So now, how do we actually solve it? Since I've drawn it really big, I can't fit it on the screen anymore. But what we notice, lots of different ways we can do this one. I'm going to go with let's first take our cosine equation from here. So cosine of 30 would equal Vp times t plus 3 seconds over V naught t. Right? So that tells me that my velocity of my player times my 3 seconds plus the velocity of the player times t equals a V naught cosine 30 times t. So if I can find t, since I'm given that, then I can solve for V naught. So if I look up here, I see that in this case, it's the sine. I'm sorry, it's the tangent once again. Is that what I want? What am I going to go for? No, I'm actually going to go for the sine in this case, because it turns out to be nice. I went for sine of 30 equals 1/2 g t squared over V naught t. Now you might ask, why did I do that instead of the tangent? Could have done either one. Tangent would have given you t as well. This one, I can see my t's cancel, and I have a nice expression for V naught. V naught equals, I'm sorry, I'm doing it slightly backwards for you guys. This is what happens on Friday. I have time equals 2V naught sine 30 over g that I can plug into here. And then I can get a nice funny math equation for V naught. Where I know all of this and I know all of this. The reason I did this for you, like I said, this is the problem with doing the algebra. There's lots of different ways to do it. This one I wanted to show you that sometimes we were only getting quadratic equations for t up to now. I wanted to show you sometimes you get quadratic equations for other things like V naught. And you can do it where you get weird coefficients and then you plug in the numbers. I will actually, this one is a fun one because there are 2 or 3 different ways to do the algebra. So I'll make a little video for you of different ways to do the algebra so you can see which one makes the most sense to you. But here I just plug in for this number and this number. And I get 0.0866 V naught squared minus 0.6 V naught minus 18 equals 0. And so I would get a V naught equals 18.3 meters per second and a minus 13.85 meters per second. And again, I wanted to show you this to remind you that we often get 2 numbers when we do the quadratic, and we have to make a decision which makes sense. In this case, of course, for our friend to catch it, which one must I pick? The 18, because are they going to catch it if I throw it backwards? No. Okay, so that is related to a completely different situation that would give the same equation. So this is the one we pick, and we pick it based on the physics. Any questions on that? I apologize for the little glitch there in the middle. But again, the process here was if I had t, I knew I could solve for V naught. So I got an expression for t. And even though it had V naught in it, this will happen occasionally. Notice I could not get a number for t at this point. And that is something that often will make you, yeah?
Where did you get the 12 sign from?
The picture that disappeared. So the cosine of 30 was the adjacent over the hypotenuse. The one we've done, we'll do that a lot. That'll show up a lot. And another reason, in addition to showing you that you get these funky equations sometimes, notice if all you like to do is have numbers to plug in, which is very common, you get here and you're like, oh wait, I can't get a number for t yet because I don't know V naught. But that's okay, because v naught is what I want to solve for, I just plug it into here anyway, and I get my equation for v naught, and I can solve. Now, you might have plugged in what the sine of 30 and what 10 is, and then multiplied by 2. So you might have had one number times v naught if you don't like keeping variables around. And then you would have plugged that in, and you would have gone straight to this equation here. So depending what you did here, you would either go what I did to there or straight to there. But the main point is, do not panic if you don't have a number yet for t. If I haven't asked you for the time, if all I'm asking for is the velocity, you're good at this point. And that's part of the algebra that you need to recognize. Any questions on that?
Question.
Oh, good. Where? Oh, thank you. Yes.
Where is the velocity for the person with the unknown time?
Oh, I just plugged in for it. This person was given as 6 meters per second.
Okay, never mind.
Yeah. I know it's hard because we don't have the question on the board at the same time. I keep telling Irvine to put 2 screens in every lecture hall. So I can put the question here and solve the problem there. Wouldn't you like that? Yeah, so write them. Tell them, we need 2 screens. Actually, you may not want to do that because then they'll raise your tuition. So you kind of have a choice. 2 screens and pay more money, or just suffer like this. That's the one reason. Keep in mind, I've told you, I post the problems ahead of time. And so you can print it out and just have that written for you to keep track of what the question is. I really encourage you to do that. Now, any other questions? This time I'll actually look up when I ask that. So let's just have a follow-up question. How long is the pass? Okay? And I'm just going to do that right here. We already saw that delta x of the player was 6 meters per second times time plus 6 meters per second times the 3 seconds that was delayed. And we had an expression for time. We got this as part of solving the problem. And now that we know v naught, we can just plug in and get 1.83 seconds, plug in here, and we find out we ran 29 meters. So we had roughly a 30-meter pass. So a lot of times, and you'll see this in the homework in the Mastering Physics, the funny thing is, they'll often ask you things like they might have asked, how long was the pass? How long was the ball in the air? And so things that you solve for as part of part A might just be the answer to part B. So you want to watch for that a little bit. Any questions on that? Now, when I post the solutions, it'll also show the components. And like I said, I'm going to show a couple of different ways to do the algebra on that one, just as a little algebra review for you. Now, we have a very important activity. Okay? In preparation for the exam next week, what I would like you to do is make a list for yourself of all the parts of an object's motion that you would like to know when solving a problem. Aspects of an object's motion. So like not its color. You know, not whether it's a ball or a car or a boat or a plane. What things about its motion are useful in solving a problem that's about motion, that is about things being somewhere at a certain time. And that is one idea you really want to keep in mind. If the problem is about being somewhere at some time, it is probably a kinematics problem. And that'll be true through the rest of the course. If at some point in the course of a problem you need to know that something is a certain place at a certain time, you're probably going to have to do kinematics at some point in the problem. You may have to do other stuff as well, but at least part of it will be that. So if you want to know that, what sort of things should you know? As you write your list, feel free to shout a few of them out now.
Time.
Position, time, initial velocity, final velocity, acceleration. Is there anything you want to know about the acceleration? Positive or negative? Something even more basic. The first question you might ask about the acceleration. Is it constant or not? And then is it 0 or non-zero? So here's my list. Notice I did not put time on the list because I don't consider time to be part of its motion. It's what we're using to describe its motion. But you can put time on the list. That's perfectly fine. I don't have a problem with it. Okay? The main things about it are its initial velocity, final velocity, acceleration, initial position, final position. Because what you're going to want to do is be able to draw v naught t plus 1/2 gt squared equals delta x correctly. You're going to want to be able to draw v naught gt v final correctly. And I've often drawn them like that, but of course it could be something launched up and is still going up, right? So that would be v naught plus gt equals v final. It could be something launched down that lands somewhere. So that could be v naught t gt squared with a 1/2, and that's delta x. So there are all sorts of variations on these types of things. Notice you need to be very alert if anything's happening to the acceleration. We had a lot of problems where I was moving with a constant velocity, so I had 0 acceleration, and then I started to accelerate to catch the object. So I had to break that into 2 pieces. I had to break it into the 0 acceleration and the new acceleration. Or I might have been driving along and I suddenly had to brake, so I went from 0 acceleration to a negative acceleration. Or maybe I was accelerating, realized I wasn't catching the person, and now I have to accelerate faster. So I have 2 different positive accelerations. So you want to watch for that. And then, we didn't call it this, but you want to watch for objects in the way. Do I make it over the field goal? Do I make it over the wall? Do I make it over the tennis net? Do I clear whatever it is I'm trying to clear? That would be an object in the way. You know, what other objects am I interacting with? Any questions on that? Now, this is just, I'm going to post this with it. We're not going to do it now. But these are 5 key things you're going to want to review as you do the homework this weekend and before the test. You want to make sure you know what top of the flight means. You want to make sure you know what it means to just clear the object. You want to make sure you know what minimum speed to clear an obstacle means. You really want to know what to catch or to hit an object means. So those are 5 big main ideas from the course. Okay? And lastly, a very important thing I've said a couple of times, and I want to say again. So let's suppose we were doing that football problem that we just did. If I did my standard thing, what I want to find is v naught, and I'm given the velocity of the person, the delay time, so that's the velocity of my friend, that's the delay time, and I always know g, the acceleration due to gravity, and I was given the angle of the throw. But having done this list, I just wanted to re-emphasize our last point. Notice nowhere in here does the time for the throw show up easily. But once I draw my picture, there's no way to draw my picture without including the time of the throw. And so I immediately realize I have 2 unknowns. The danger up here really is, and again, you might laugh when you see it here in the calmness of class, but you write down delta x equals v naught t plus 1/2 at squared, Oh, great, I have time. And I just plug in 3 seconds everywhere. Because a time was given to me. I'm matching my variables to my equation. It is a good way to initially learn about solving problems, to match your variables to your equation. But for most of the problems we do, it will mess you up. So the standard list your info, match equation, and then solve the problem doesn't really work great. What you really need to do, everything we've been practicing, which will take you through the rest of the class, is identify the physics, identify the motion. Is it constant acceleration? Are there 2 accelerations? Are there 2 objects or 1? It's amazing. Everyone senses it's over. Then you look for the relevant information in the problem, and then you solve it from the equations. And apparently lecture's over, so we'll see you next week. Again, I do have office hours about 2:05 over in Frederick Reines Hall.